So we are going to discuss about the hypothesis testing. But first of all, we need to understand what exactly the hypothesis testing mean. Okay. As a part of it, we need to understand the types of hypothesis. What do you mean by hypothesis? Uncertainty of accepting a single answer for a question, right? Hypothetical. How many of you heard about this name or a term or a word? Hypothetical. Huh? I hope that you all can see my screen. Please confirm. Hypothesis testing. Okay. So there are two types of hypothesis. First of all, we need to understand what is hypothesis. See, we know we are all struggling a lot in order to identify the population parameter. Can anyone tell me what the entire statistics is revolving around? General question. It is revolving around identifying a mean or comma variance or a standard deviation. Okay, identifying these three things either for a population or for a sample, right or wrong? For a population, if we have the data, we know the formulas. For the sample, we have a many methodologies to identify, which is quite related to the population data. This is what our main ambition, right or wrong? In the statistics I'm talking about. So this is the population parameter. We are struggling a lot in order to identify or estimate the closest population parameter, whether it is in that range or not. It is an assertion about its value. Agree? Testing the truth between two competing hypotheses, that is called a null hypothesis. Null hypothesis and alternate hypothesis. Understand? Null hypothesis and alternate hypothesis. I will tell you in brief, no issues. I will tell you what exactly that we can define the hypothesis testing. Hypothesis testing is a statistical procedure. We know that. It's a statistical procedure in which a choice is made between a null hypothesis and an alternative hypothesis. Okay, that's it. So now, what is the end result when we are doing this hypothesis testing? You will have a certain population parameter, right or wrong? So, and there should be an estimation of the answer or of one particular population parameter. When you are doing this testing procedure, you may reject the null hypothesis hypothesis testing is nothing but, for example, let me say, I'm going to claim I have a notebook shop. I'm going to claim the average price of the notebooks is around 28 rupees. That is my claim actually. Okay, I'm telling that it is a fact, but how can you evaluate that fact? By using the hypothesis testing. How can you evaluate by using the hypothesis testing? What do you mean by hypothesis testing? The claim which was made by someone, the value which was claimed by someone, the price which was claimed by someone, which is 28 rupees, is needs to be, I mean, whether that price needs to be considered or rejected. Okay, are you going to accept that value or are you going to reject that value? You have to make your decision based upon your calculation. That kind of testing is none other than the null hypothesis testing. Okay, so in null hypothesis you need to understand there is, I'm sorry, in hypothesis testing you will have two types of hypothesis. One is null hypothesis and another one is alternate hypothesis. Okay, whenever I say the average price of the notebooks that they are selling since from the past 1 year is 28 rupees, let me say. So the statement about this population parameter that is assumed to be true, okay, that is always assumed to be equal to null hypothesis. Now the null hypothesis is equal to average of all the notebooks since from the past 1 year, which is 28 rupees. Okay, it is going, now the null hypothesis is equal to 28 rupees. Unless and until there is a convincing evidence to reject this null hypothesis, it is going to be true. If you could not be able to prove that the average price is not 28 or 30, otherwise 30, okay, you can't make the 28 rupees as wrong. Once you make it wrong, then it will become alternate hypothesis. Alternate hypothesis is a statement about a population parameter which is contradictory to the null hypothesis. Understand or not? I will say I'm an average book price since from the past 1 year I'm selling as null hypothesis, which is H naught is equal to 28 rupees. Do you agree this or not? If you agree, then it is null hypothesis is accepted. You are going to accept it or not? Or you want to reject it? Then the rejection of the null hypothesis is nothing but alternate hypothesis, which you are going to get a calculation based upon the calculation of the data, and that data will become the value for the null hypothesis testing. So which is going to become the alternate hypothesis. Understand? So hypothesis testing relies on two different values. One is null hypothesis H naught and alternate hypothesis. One second. Null hypothesis H naught and alternate hypothesis HA. Okay, H naught is always considered as a mu, which is going to be average price or 28 rupees as I said. Alternate hypothesis needs to be measured how much it is going to be. Okay, alternate hypothesis may be accepted or rejected based upon the null hypothesis. Let us understand how it is going to be. So at the end of the, understand that at the end of the, there are only two chances. One is reject null hypothesis, try to reject null hypothesis, or fail to reject null hypothesis. Fail to reject null hypothesis means accepting the alternate hypothesis, right or wrong? There are only, but still as per the researchers, this is how that we need to think on. Reject the null hypothesis or fail to reject the null hypothesis, which is obviously equal to H alternative hypothesis. Are you all with me? Any questions? Shall we go ahead with an example? Okay. Now what I'm saying, a publisher of the college textbooks claims the average price claims an average price of all college textbooks is $127. Okay. A group of students believes that the actual mean is higher. Okay. So now you are there to test this belief. Okay. So by default, now how? So now what is the, now we are going to we are not going to calculate anything else here. Now what we are trying to identify here is, can you please tell me what is null hypothesis and what is alternate hypothesis? That's it. Hmm? So null hypothesis is equal to mu, which is going to be 127. Okay. Alternate hypothesis is expected that the students group are thinking that it might be greater than 127. Okay. Understand? All of you, are you good? Shall I go ahead with one more example? You want one more example? Okay, solve this then. The recipe of a bakery item is designed to result in a product that contains 8 grams of fat per serving. Okay, they have designed one recipe, okay, which gives the 8 grams fat for serving, whereas quality control department came for scrutiny and they have verified the samples of the product periodically to ensure that the production process is working as designed. Okay, so can you please verify H naught and alternate hypothesis? Tell me this. Okay, H naught, it is saying, Narayana is telling that it is 8 grams, right? Okay, okay. What about alternate hypothesis? See, how can both of them are equal? They're contradictory, right? Remember one thing, H naught is not equal to H here. Remember that part. Anytime. These two things will never, these are all perpendicular. Both of these two things are perpendicular. You can't make a combination. Why? Because see, for example, let us take our government. There is always a ruling government and an opposition government. Will you make them same as ruling? No. There should be always a opposition. That's it. The same way, whenever there is a truth, there should be some altercation where it needs to be identified whether the truth is truth or false. I told you the quality control department is frequently coming and checking the in production process. In what sense that they will check the production process? Maybe this fat percentage of 8 grams is not equal to 8, maybe 9 or 10. This is the intention that they will have. So not equal to 8. Right or wrong? You can't say greater than or you can't say less than in specifically based upon the comments that we have seen in the examples. If I'm going to tell in the previous example, students told that definitely the price of the mean price of the textbooks will be greater than, I mean, generally the actual mean is higher than what the publisher told. So then what happens? H alternative will be greater than 127 in the previous example. Understand? So let me just tell you only one thing here. When you have when you have a null hypothesis as mu, the alternate hypothesis will have 3 levels or 3 types, which is greater than, okay. For example, mu is equal to mu naught. Okay, mu naught might be the value. Okay, h naught h a colon mu may be greater than mu naught, maybe less than mu naught, maybe not equal to mu naught. Is there any other sense that we can make it apart from these 3 about the alternate hypothesis? No. Either it should be less or either it should be greater than, or otherwise it should not equal to. That's it. Okay. I hope that you understand the logic. Okay. So coming to the problem. Okay. Here we have to say we will go ahead with the probability distribution, right? That may be a normal standard distribution, whatever it is. It is expected this is how it looks like. This is going to be mu naught. Okay. So if HA alternative hypothesis is having something less than mu naught, then reject null hypothesis. Huh? You have to reject the null hypothesis. Why? Because there are 3 ways of rejecting. There are 3 ways of rejecting the null hypothesis when your alternate hypothesis of the mean is less than mu naught or greater than mu naught or not equal to mu naught. When it is less than mu naught, the critical values will comes on the left of the mu naught, means you will get the critical values over here. Okay. When it is greater than, then you will get the right side of the critical values. When it is not equal to, you need to consider the both sides of the critical values. Okay, generally these things could be called as a rejection regions. Okay, when you are considering the left hand side, okay, if you are going to consider this as a C, which is a critical value, C minus infinity comma C. I can say like this, right? If you are going to consider about the greater than mu naught, then it will become, this is also C, or it will become C comma infinity, right? What about this one? Both sides not equal to. What you can say, minus infinity comma C union C comma infinity. Okay. So that's why we will call these as critical values. These are critical values. Okay. We know how to identify these critical values very well. Okay. How this is going to work? How do we identify the critical values, guys? Huh? Jet distribution, right? We will take up the jet distribution. I will tell you. I will explain you one concept. Okay. I will explain you one example on this one. Let us take one example. Okay. The same bakery example I'm going to take up. Okay. I'm going to take up the same bakery example. In the bakery example itself, it is understood that the population is normally distributed. Population is normally distributed with a standard deviation of 0.15 grams. Okay, and the test of hypothesis should become H naught colon mu is equal to 8, and whereas H alternative hypothesis mu is not equal to 8. This is what we can tell. Okay, this is always performed. This is actually, this is the sum that I'm talking about. Okay, where it is performed with a sample size of 5. Okay, so what is the question here? They are asking to construct the rejection region okay, for in the 90% confidence intervals, otherwise alpha is equal to 0.10, however it is. Okay, consider the rejection region and explain the decision. This is what they are asking, explain the decision. So now, based upon this part, we know everything. Okay, we know what is mu. Mu is equal to 8. Then you need to identify the sigma. Sigma is equal to sigma by root n. Okay, 0.15 divided by root n, which is 5, which is close to 0.067. Okay, now alpha has already given, which is 0.10, right? Now, is this a two-tailed or one-tailed? We know that this is the distribution, how it looks. Okay, is it two-tailed or one-tailed? Two-tailed. Why? Because alternate hypothesis is not equal to, so you can't say less than or greater than, so you need to consider two-tailed. Okay, so can you, so I'm going to make alpha divided by 2 is equal to 0.10 divided by 2, which is going to be 0.05. Understand? So now you tell me, What is the Z distribution for the 0.05? Z 0.05 is equal to what's the Z 0.05? Are you verifying or not? If you are not going to verify, I will verify. Please tell me. What is the Z distribution value for the 0.05? Anyone? Okay, it is not 10 actually, it is 1.645, which is Z is equal to 1.645. Okay, we have the Z value. Now, what we can say, Z is equal to 1.645. Okay, so we have the critical values. Okay, left value minus 1.645, right value plus 1.645. So once after we do the calculation, we need to verify that one. So we need to verify the critical values here, actual critical values. Okay, which is mu minus Z into sigma. Okay, how I have derived this one? Z is equal to x minus mu divided by sigma. Okay, x is equal to mu minus Z sigma. So if you calculate this part, x1 or xi is equal to 8.0 minus 1.645, okay, into 0.067. This is how we have calculated the sigma is equal to sigma root n, right? Okay, sample size of 5. So we have got the sigma value as 0.067. So you are going to get the value as 7.89. Okay, x2 means c1 or c2 or x1 or x2, however you want, you can name them as like that. So now tell me 8.0 minus 1.645. Okay, sorry, plus 1.645. Why? Because this is plus or minus, right or wrong? Huh? Plus or minus 0.64, 0.067. Okay. So how much is going to the value? 8.11. Got it? 8.11 and 7.89. 8.11 and 7.89. So can you please tell me 7.89 will come under the rejection region? Huh? Guys? See, basically, we have got two values, x1 and x2. This is 7.89. Okay. Actual mean is 8.0, which is mu. Okay. And we have one more thing as 8.11, which is 8.11, let me say. So we should get two different rejection regions. Okay. Two different rejection regions. If you can take a look at this one, we can say the decision as when we have taken a sample of size 5 and we calculate the sample mean, it is either 7.81 or 8.11 grams. Okay, understand or not? So here, once after we calculate this one, why? Because always the quality team are trying to say, whenever they come, they will try to analyze the fat percentage or the weightage of the fat should not be, it might not be 8 grams. That is how that they will come. That's why the alternate hypothesis is 8 grams is not equal to 8 grams. Null hypothesis is a 8 grams. Okay, so here whenever we have seen that it is not equal to, then that may be lesser or that might be greater. 7.89 should work, otherwise 8.11 should work, right or wrong? So here, if it is either 7.89 or less or 8.11 or more, then reject the null hypothesis. Understand or not? If it is less than, means this is the rejection region. Okay. If the result is going to fall under this part, you have to reject this. Otherwise, if it is falling under this part, you're going to reject this part. Okay. Right? So here, the reasoning is that if the true average amount of fat per serving was 8 grams, then there would be less than 10% chance that a sample of size 5 would produce a mean of either 7.89 or 8.11 grams or more, 7.89 grams or less. Okay, so you are going to have the two different stuff. So hence, if it is going to happen, it would be more likely that the value 8.0 is incorrect, always assuming that the population standard deviation is 0.15 grams. Understand? Okay, see, we will not reject the hypothesis if it is going to be the average amount, which is 8.0. Understand? So this is completely relied on the tails of the distribution, how we are going to work with that. Okay, all of you with me? Understood? We will see a couple of more examples in the tomorrow session. Okay. Okay. Okay, guys. See you all. We'll meet again. Bye.